Let us see some previous gate questions, some of them which have come in the Fourier transforms. Let us start with the first question. The first question is, the Fourier series expansion of a real periodic signal with fundamental frequency f0 is given by GPT is given by Gp of t is equal to summation n is equal to minus into plus infinity Cn e to the power of j2 pi f naught t. It is given that C3 is equal to 3 plus J5. Then C of minus 3 is how much? This question was asked in the year 2003. Okay. So, here significant points which you take from this question are, in the question it is given that the signal is periodic and also it is real. And then one coefficient C3 is given, and then we are asked to find out what is C minus 3. So, because the signal is real and periodic, okay, C3 is given. C3 is given as 3 plus J5. 3 plus J5. Now, we are asked to find out what is C minus 3. Okay. Because this is real and periodic, C of minus 3 will be a complex conjugate of it. So, the answer will be minus 3 J5. So, this is my answer. So, let us see what is the answer here. The answer is D. Second question is like this. The Fourier transform of a conjugate symmetry function is always A. Imaginary, B. Conjugate antisymmetry, C. Real, and D. Conjugate symmetry. The answer is C, that is real function. So, for a Fourier transform of a conjugate symmetric function is always real. The answer is real and the option is C. Let us see question number 3. Let x of t and y of t with Fourier transforms x of f and y of f respectively be related as shown in the figure below. Then y of f is, this question is asked in the year 2004. We have 4 choices. The choices are minus half x of f by 2 e to the power of minus j2 pi f, B minus half x of f by 2 e to the power of j2 pi f, C minus x of f by 2 e to the power of j2 pi f, and D minus x of f by 2 e to the power of minus j2 pi f. Okay. The answer is B. Well, let us see how it is like that. Okay. Now, x of t has been given and y of t is also shown in the form of a graph. Now, we have to establish a relationship between x of t and y of t. If you look at that figure, y of t is x of 2t plus 2 and minus, because it is in the negative axis. So, this is the answer. Now, to find out a solution for this, you should understand or what are the Fourier transform properties which we should use here. One of them is, this is one property we have to use and this is another property which you have used. That means, here we are using both time scaling and also time shifting properties. So, time scaling and time shifting indicates the presence of what? A scaling factor, okay, that is 1 by A, and the frequency also gets divided by that factor A. So, this is because of time scaling property, because there is a scaling of time here, and also because of the time shifting property there will be an exponential term involved indicating the presence of a time shift property. So, looking at these two, the answer is B. Okay. So, what is the answer? The answer is minus half x of f by 2 e to the power of j2 pi f. A is not correct because here the shifting is on the, it is shifting is minus t. Okay. So, that is minus 2. So, shifting. The answer is B. Okay. Because we have to see some elimination. How can we eliminate? So, if you look at A and B, the answer has to be chosen between A and B, of course, because you see there is a scaling involved. Whenever there is a scaling involved, as per the time scaling property, there will be a factor 1 by A. So, A and B choices have that property, whereas C and D we do not find them. So, C and D can be right away eliminated. We need not worry about them. So, C and D can be removed. Now, comes the second point where there is an exponential term is involved. So, you have to choose what is the exponential sign of the exponential power, whether it is minus or plus. So, here the answer is B, that is minus half x of f by 2 e to the power of j 2 pi f. Let us see the next question. The next question is, a rectangular pulse s of t is shown in the figure below. He is convolved with the signal cos square 4 pi into 10 to the power of 3t. The convolved signal is, there are 4 choices given. A is DC signal, B is 12 kilohertz sinusoid, C is 8 kilohertz sinusoid, and the D is 14 kilohertz sinusoid. So, 4 options are given. So, we have 2 signals that are being given. One is a rectangular pulse, which is having a t is equal to 0.1 millisecond, and also you have a cosine function. Now, if you look at this, the convolution of these two. So, let us see what is the frequency of these two. Now, the rectangular pulse is having a frequency, rectangular pulse is having a frequency of 1 by 0.1 milliseconds. So, this is equal to 10 kilohertz. Okay, this is my first rectangular pulse. Then comes the second, a cosine function is given. Okay, if from the cosine function equation, the frequency of that is 4 kilohertz. Now, when these two are convolved, the result will be a signal which is sinusoidal having a frequency of how much? These two, that is, it will have a frequency of 14 kilohertz. So, the answer is D. Now, we have a fifth question here. This question was asked in the year 2005. For a signal x of t, the Fourier transform is x of f. Then, the inverse Fourier transform of x of 3f plus 2 is given by A, half of x of t by 2 e to the power of j 3 pi t, B, 1/3 x of t by 3 e to the power of minus 4 j pi t by 3, C, 3x of 3t e to the power of minus j 4 pi t, and D, x of 3t plus 2. These are the different choices. So, if you look at this, this happens to be a frequency scaling. So, you have to apply duality theory and then find out inverse Fourier transform of this. So, what is the answer here? The answer is B. If you see, the scaling of frequency is 3. So, it will be 1 by 3. So, if you look at all the choices, there is no 1 by 3 in A or C or D. It is only present in B. So, you have to apply that property. So, 1 by 3 is actually the beginning of your answer. So, 1 by 3 and then scaling properties in it. So, it will be x of t by 3. So, that is also there. Because there is a frequency shifting, there will be a exponential factor. So, the answer is B. Now, the question 6 is, the Dirac delta function is defined by. This question was asked in the year 2006. There are 4 choices given, and these choices are A, delta t is equal to 1 when t is equal to 0 is 0 otherwise, delta t is equal to infinity when t is equal to 0 and 0 otherwise, C, delta of t is equal to 1 when t is equal to 0 and is 0 otherwise, and integral minus m to plus infinity delta of t dt is equal to 1. Then the next section D is delta of t is equal to infinity when t is equal to 0 and 0 otherwise, and integral minus m to plus infinity delta of t dt is equal to 1. The answer is D. Okay, this is from our definitions. Now, let us see the answer here. So, the answer is D. Question number 7. If x of t has a Fourier transform x of j omega, the Fourier transform of the signal x of phi t minus 3 in terms of x of j omega is given by. Okay, this question was asked in the year 2006 and the choices are A, 1 by phi e to the power of minus j 3 omega by phi x of j omega by phi, B, 1 by phi e to the power of j 3 omega by phi x of j omega by phi, C, 1 by phi e to the power of minus j 3 omega x of j omega by phi, and D, 1 by phi e to the power of j 3 omega x of j omega by phi. So, if you look at this question, the elimination which we have done earlier, a little bit we have to be careful here. If you look at it, this again involves scaling and also time shifting. So, 2 properties are involved. So, scaling means 1 by 5. If you look at all the choices, in all the choices 1 by 5 is there. So, we cannot right away eliminate any choice because 1 by 5 is present in all of them. And in fact, x of j omega phi is also there in all the 4. So, elimination has to be a little bit careful here. So, now, because scaling is been taken care by all the questions, now the only option left for us, we have to take care of the exponential, because there is a time shifting that is happening, so there will be an exponential term involved. So what is that exponential term? The answer is A, that is 1 by 5 e to the power of minus j 3 omega by 5 x of j omega by 5. So this is the answer. If you look at the second, where we are now talking about the time shifting property, then we can right away eliminate C and D because that 5 factor is not involved. You have to be very careful here while eliminating. Almost all the choices here are same. The answer is A. Let us see question number 8. The Fourier transform of signal h of t is h of j omega is equal to 2 cos omega into sin 2 omega whole divided by omega. The value of h of 0 is how much? This question was asked in the year 2012. The choices are A 1 by 4, B 1 by 2, C 1 and D 2. Look at this, the h of j omega is given in terms of cosine and sine. So convert this into sinc functions. Essentially h of j omega becomes a sinc function. So h of t will be a rectangular function. So the answer is C, that is 1. Question number 9. The ninth question is, a real valued signal x of t limited to the frequency band of mod f less than or equal to w by 2 is passed through a linear time invariant system whose frequency response is given by h of f, which is equal to e to the power of minus j 4 pi f for mod f less than or equal to w by 2 and 0 for mod f greater than w by 2. The choices are A x of t plus 4, B x of t minus 4, C x of t plus 2 and D x of t minus 2. So the answer is D, that is x of t minus 2, because the transfer function is adding a exponential to the input. That means whenever there is an exponential function, it is an indication that the input signal is shifted in a time domain. So the answer is D.